A limit is the concept important for the calculus part. Let us see the definition of limit here. Suppose f of x is a function in the variable x. Clearly it f of x, here the variable is x. If the variable x tends or approaches to a particular value, that particular value is a, then the function tends or approaches to a particular value, that particular value we call it as L. So here the function approached value L is called the limit of the function. L is called the limit of the function f of x. Here the function name is f of x. So to understand this definition, let us see the one example here. Given function is f of x is equal to x square. Find the limit of f of x at x is equal to 2. So to find the limit of the given function here, the given function f of x is equal to x square. Now given x is equals to 2. So here x is equal to 2 means x approaches to 2 only. X approaches to 2 only. Approaches can be denoted as arrow mark. Here arrow mark indicates tends or approaches. Okay. Here x approaches to 2 means we assume x value is equal to 2. Then the function value f of x is equal to x square approaches to which value? We need to find here. So here x approaches to 2, f of x approaches to what value? That is the value we need to find here. Therefore f of x is equal to, if we put x is equal to 2 in this function, 2 square is equal to 4. So clearly x approaches to 2, here f of x value approaches to 4. Here 4 is called limit of the given function f of x at x is equal to 2. So clearly we conclude that if x approaches to 2, then f of x approaches to 4. Here 4 is called limit of the given function. So from this example and from the above definition here, this definition can be written in symbolically as what is the notation here? If x approaches to a, then f of x approaches to L is denoted by a limit x tends to a, f of x tends to L. We read it as a limit of the function f of x as x tends to a is L. So from that we have a note, if x approaches to a, this means the all values of x near to a, either from a left side or from the right side. To understand this point, let us check the graph here. This is horizontal line, x-axis, and this is the vertical line, call it as y-axis. This is the origin, we know. Suppose on x-axis x tends to a means x is equals to a. On x-axis we take a point a here. So all x values approaches from the left. This indicates, this arrow mark indicate all x values approaches to a from left. This arrow mark indicate all x values approaches from left, and this is from right. Okay, so these all arrow marks, this arrow mark indicate all x values approaches to a. So if all x values approaches to a from left or right, then the functional value is approaches to some fixed point. That fixed point lies on y-axis. So from this graph, we conclude that if x approaches, all x values approaches to a from left, then the functional value can be denoted as limit x approaches to a minus f of x. Okay. If all x values approaches to a from right, then the functional value is can be denoted as limit x approaches to a plus f of x. Okay. From this, we conclude that limit x approaches to a f of x can also be equals to limit x approaches to a minus or a plus f of x is equals to limit x approaches to a minus f of x. Okay. Now, algebra of limits. What are the algebra of limits here? Let f and g be two functions such that both limit x approaches to a f of x and limit x approaches to a g of x exist. These limits exist at x is equals to a. Then we have limit x approaches to a f of x plus g of x is equals to limit x approaches to a f of x plus limit x approaches to a g of x. Now the second point is limit x approaches to a f of x minus g of x is equals to limit x approaches to a f of x minus limit x approaches to a g of x. And third one is product limit x approaches to a f of x into g of x is equals to limit x approaches to a f of x into limit x approaches to a g of x. And fourth one is quotient form. Limit x approaches to a f of x by g of x, numerator by denominator form. Then the limit can be applied to numerator as well as denominator. Limit x approaches to a f of x by limit x approaches to a g of x. Here the denominator value should not equals to 0. Now the fifth one is limit x approaches to a some constant into function form. Suppose c into f of x. Here c means the constant, f of x is the function of x. Then c into limit x approaches to a f of x. So c can be taken it to outside in this case.